Hello everyone and welcome to video number 14 of this series in which we are learning how to model an end plate steel connection, which is this model that you see here. We have already finished the first version of this model in which we have modeled the bolted connections using a coupling here, another coupling here, and then a beam element and translator connector for bolt pretension. Now we are creating the second version of this model in which we are going to model the bolted connection using solid element. So this is a more detailed modeling approach for the bolted connections, and you should use it when you're interested in calculating with more accuracy the stress and strain and displacement and everything else around the bolted region, bolted connection region. Okay. Well, in the previous video, we have started working on it. We have created the bolt using second order theta Hessian elements, fully integrated. We have modeled the washer using first order ANSA with incompatible modes, which is a good formulation. And now we're going to model the nut here. We can also have a washer and then a nut, but to facilitate, we're going to just consider a nut without a washer. And as an exercise, you can add this washer on this side as well, using the same modeling strategy that we are going to use. Okay, so if you'd like to, just follow what I'm going to do, considering just the nut on this side. And then as an exercise, you can add a washer on this side as well, using the same technique that you're going to learn. Okay. All right. So let's do this. First of all, just to be sure that you have the same setup that I have, choose here Abaqus deck so that you have the same structure of the database. In the draw mode, let's select PID, and in the yellow buttons you should have everything that I have activated. In this one, deactivate spots and hot points. And in the pink buttons, you should have these three activated, and I guess that's it. In the database, activate visualization of point and curve. And let's do one thing here. Let's delete all points and curves, because now we are going to create some new ones, and I don't want to get confused by the ones that exist already in the module. So double click on curve, Control A on this list, right click and delete. Okay. Now double click on point, right click and delete, and okay. Now let's use the knot tool, PID selection mode. Select this PID here, middle mouse button. We are going to use the same technique that we have used before to create the washer. So I'm going to be faster here. Select classic topo module. Let's create a point on COG of circle, zoom in here, select 3 nodes that is part of the circle, middle mouse button, and then let's use the move tool, transform, move, select entities, select this node, middle mouse button. I want to move in the positive X direction by, well, the thickness is 20, so half of the thickness is 10. 10 plus finish. Now I want to create a working plane, new, normal to, actually parallel to the YZ axis, and then I'm going to select this point here, and then middle mouse button, auxiliary entities part. I'm going to have the working planes visible by checking this box. I'll double click on this, and then you see that we have other working planes as well, right? let's do one thing here. We don't need anymore the other working planes. I'm going to increase the size of this, and then I'm going to delete, I can't delete these ones, but I'm going to delete all these ones here, except this one that I have just created. Right click and delete. Okay. I just kept this one that I have just created. And now let's use the tool to create a curve, create 2D, select plane, select this plane here. Now create a circle and select this point. And in part, let's select ask all is here. Ask all is here. Let's get this horizontal line, position the mouse here, space, and the radius is going to be equal to 10. I want the internal radius of this nut to be equal to the radius of the bolt. We know that in reality we have the thread of the nut, we have the thread of the bolt, but we are not going to model the thread of these two entities. And I'm going to explain why shortly. Let's continue here. He's asking what part I want to include this new curve. I want to select here in model browser auxiliary entities. Oh, well, ANSA. Sometimes we have this issue with ANSA. ANSA has stopped working. Do you want to save the database and restart? We were lucky that we have this option to save the database and restart. Sometimes ANSA just closes and we lose all the job. So in this case, I'm going to click on save and restart. I'm going to save here with a name v2 because I'm not sure if this is going to be saved properly. I don't want to overwrite the previous version. Let's just wait. ANSA is restarting. And now in here, open recovered database file, click on OK. And let me just set up some things here. Okay, looks like everything is okay. Maybe I lost the curve. Let me see if I have lost the working plane. No, I do have the working plane yet. I have just lost the curve. So let's create it again. Classic topo module. And by the way, let me lock this view by clicking here. And then create 2D, select working plane. Let's have this working plane visible. And then I'm going to select this working plane. Uncheck this box. Circle, zoom in, select here. Space, 10, press enter. In this case, I have here use existing. That's okay. We're going to delete this curve later, so it's okay to put it in any part. This is the inner radius of the nut, and let me create here the outer radius of the nut. And again, this is something that obviously that in a real work you should use some type of catalog of the nut that you're going to use here. So that you're going to create the CAD based on this catalog, or maybe you're going to have the CAD of this part ready, and then we can import a step file here in ANSA and mesh it. But in here we are simplifying these. I'm doing this because we end up practicing some important tools. So I'm going to just define this outer radius maybe as, I don't know, 18. Okay, so position the mouse here, space, and 18. Press enter. I guess this is good enough. And again, let's create line from here to here, middle mouse button, from here to here, middle mouse button. It's a very similar procedure to the one that we have followed for the washer. Project hot point. this is a hot point. I want to project this hot point on this curve. Select this hot point and this curve. We are splitting this curve in two when we do this. This hot point on this curve, this hot point on this curve. Okay, now you see that we have some curves here, and now we have these divisions in these curves. New face, planar. Let me hide this mesh here by unchecking these. And also let's uncheck the macros visualization. Now let me create by selecting these cones, middle mouse button. Let's assign this to this temporary property that we have created. Click on OK. We are not able to see it because I don't have macros visible. That's okay. Let's have macros visible, and actually let's use the not function and hide this back PID selection mode and hide this back macro. Deactivate the not function. You see that we have two functions activated here. Deactivate the not function by clicking here. And then let's create a new face by selecting these cones. Middle mouse button. And check curves here. Now we have a yellow cone here, yellow cone here. That's what we should have. Double cone, right? If you don't have a yellow cone and instead you have a red cone, you should use the topo, select everything, middle mouse button, or you can use the paste function and click here twice and etc. as we have seen before. Now, mesh parameters, click here in mesh parameters. Let's define the length to be maybe 5. Let's try with 5. Click on OK. And let's go to the classic mesh module length tool, select everything, middle mouse button, 5, click on OK. Now I want to use the inside mesh generation. I'm going to open more options to find the map tool, right click and left click and hold, select this option, create a box selection, middle mouse button. It's not looking good. Now we're going to use the number plus minus function to control the number of divisions in each cone. And then in here, choose remesh macros. And you see we have 3 divisions here and 6 divisions here. So I'm going to increase these to 4 and decrease these to 4. So to increase, I use the left mouse button, and to decrease, I use the right mouse button. So left mouse button here to increase to 4, right mouse button twice here to decrease to 4. And do the same thing here and here. Now this is looking good, right? Maybe I don't like the aspect ratio of this element. So maybe we can try to increase this to 5 and this to 5. 5 and 5. Yeah, I guess this is looking better. Yep. Now let's go to the volume mesh module, and then let's use the extrude. This is going to be a structured mesh. Let's use the extrude function inside the structured mesh group. And then in here, shells, I want to select these shell elements. Feature angle 40 degrees, select all these shell elements. I'm doing this fast because it's the same thing that we have done for the washer. Target none, rule offset. We have the correct direction, so I'm going to select default here. If you don't have the correct direction, then select inverted. Next, too many divisions. Maybe we can have here, let's see, 3 divisions per view. Yeah, this is looking good. Let me try 2 divisions. Oh gosh, cancel, Control Z. Let me Control Z. Okay, extrude. In here, let's not forget to select ask always, and in property, ask always. So again, shell, select here with feature angle activated, next, non, next, offset, correct direction. Next, let's put here 3 divisions, preview. And then the distance could be, let's see, maybe 12. Oh, I clicked on finish. It's going to be 12. Actually, it's not going to be 12 because it didn't work. Now we need to select a part. For the part, I'm going to select, I'm going to create a new part, rename it as nut. Nut is with double T, I don't know. Let's consider 1T. Double click on this one. And now I need to create a new, actually I have created this solid section property for the washer and net. So double click on this one. Yeah. Now let me close this. And here we have, let me see how much is this length here. 10. That's okay. We have some tools to modify this in a very practical manner. The morphing tools here, in the direct morphing tool, we can create a box and modify this, the length here, very easily, but I'm not going to show this because this is something more advanced related to meshing that I teach in the ANSA meshing course. So if you'd like to know about advanced tools related to meshing, then you should go through this course. Maybe what I'm going to do here, I wanted to increase this, so I'm going to simply undo. And I'm going to do this again, but really quickly this time. As always, shells, non-offset, 312 preview. I guess 12 is good, right? Now, finish. I don't have the nut. I need to create it again because I control Z. I used the control Z function. Nut. Double click. Washer nut property, and that's it. Now, let's activate the visualization of FE mode so that we can see the shell elements. You see that we have the shell elements. Let me hide this shell element using the not function property ID selection mode. We have the shell element here. This shell element has some thickness. It's connected to this solid element. It's going to add some stiffness that doesn't exist. So we need to delete this shell element that we have used to create this solid element. You see here we have shell and solid. In shell, I'm going to right click and show only. Delete function, select everything with the mouse button and click on OK. Now I'm going to click on show all, but it only shows these because we have the lock view. So unlock this view and then click in show all. And now we have the nut created. And we have used the same property as we have used for the washer. So you see that the color is the same. If we activate visualization of node, you see that we have only corner nodes. So this is a first order hexahedron element. It doesn't have the mid-side nodes. You see that the sides are straight, it's not curved. And here, when the element is a second order element, the sides are curved. In the case of hexahedrons, it's not really worth it to use second order hexahedrons. The computational cost is too high, and this element is pretty good already. But you cannot, it's not a good idea to use first order tetrahedrons, okay? You should prefer to use second order tetrahedrons. You can use first order tetrahedrons, but you need to refine the mesh a lot to get good results. Because first order tetrahedrons has constant strain throughout the whole volume. So it doesn't represent well regions with high gradients of strain. Deactivate visualization of node. Let me see here. 29 minutes. Now we can start. Let's think here. We can start creating the contacts. It's going to be pretty easy because it's the same procedure that we have followed before. You see, we have one contact defined here, this one, right? We need to modify this contact to include this region here because now we can do that, right? So let's firstly do this very quickly. Double click on this contact. We have the sets 16 and 17 used in this definition. If we want to modify, for example, this one, we can do in two ways. Use the question mark to open a list of sets. And then in here, in this one, we can right click and modify contents. Now we can insert these faces here as well. So let's do one thing here. Let's use the not function. Property ID selection mode. Select. Oh, sorry. Property ID selection mode. Select. Well, why I can't select it. Part selection mode. All right. So just deactivate the not function, and let's go one by one. So let me activate here macro area selection mode. Select this area, and let's select all these missing areas. We are going to include this in the contact definition now. Okay, middle mouse button, and then select this set to put here. And the other way we can do this is instead of doing this in here, let's just click on OK. Let's go to sets list and then search for 17 and right mouse button, modify contents. And then let's add all these missing, oh God. No, that's okay. All these missing faces. You see that it's selecting also this lower region here. It's okay. It's not really a problem. Middle mouse button and okay. Now you see that in this contact, those are the surfaces defined, and now we have something more realistic here, which is good. Now let's create the other contacts, right? Let's use this contact. Actually, we need to create some sets before, right? Let's firstly create the contact between the bolt head and washer. So I'm going to use the not function, select by PID, select this bolt, middle mouse button, rotate, deactivate the not function, set list, right mouse button, new. I want to select, well, now this is something new. Whenever you want to create a surface to be used in a contact using solid elements, you can't try to select solid elements in the database. You need to select this entity here, solid facet. Solid facet is these facets that we have for each solid element. So each side of the solid element is a solid facet, and we can select it to create a new surface to be used in a contact. So to select all these solid facets with one click, let's use the feature area tool, or we can use also here, no, it should be the feature area tool, 40 degrees, and then select this. Guys, one important observation here that I forgot to mention. Notice that we have a 90-degree angle here, right? So we don't have a radius here. But in reality, a bolt has a small radius here. We are not representing this in here, so we have a numerical singularity occurring here, which means that the stress that is going to be calculated in this region is not correct. If we try to refine the mesh, if we keep refining the mesh, we're going to find an increasing stress in this region, which means that this is a singularity. It's like an infinite stress concentration factor that we have here. Because you can imagine that the radius that we have here in this transition approaches 0. So the stress concentration factor approaches infinity. Okay, so when we get to post-process these results, I'm going to talk more about how we are going to analyze the stress in the bolt. Okay, but you should know that we have a stress singularity here. All right, now you see that I have 32 solid faces, middle mouse button. Now, here we are going to name this as bolt to washer. And then it's a surface orientation. In this case, we don't need to select orientation, because in this case, we don't have, it's orientation is only for shell element, because a shell element has a negative and positive side, right? In this case, it doesn't have. And then in here, output type element, because we are selecting element and related entities to create this surface. Now click on OK, and there we have it. Now I want to create the surface in the washer. So I'm going to use this tool here to invert the visibility of entity. So it's going to hide the bolt and show everything else. Click in an empty space. I am in the sets list, right click, new, and then select solid facet here, feature area, select this area, middle mouse button, surface, element, and this is washer to bolt. So you see one I name bolt to washer, and the other I name washer to bolt. This is what I usually do. Click on OK. And now I need to create another surface here on the other side, which is going to be in contact with the end plate. So right click, new, solid facet, select this, middle mouse button, surface, element, and this is washer to end plate. Click on OK, right click, new, and then I need to select the end plate. To see what side of the shell element we need to select, let me, here in the draw mode, select entity. Now we are able to see the sides. And in the selection mode, let's expand element group, select shell. I want to select shell element. And then you see that we are going to have contact between the washer and end plate in the negative side of the shell element, in the yellow side. Let's use a feature area and select this whole area key here. You see 436 elements, middle mouse button. Surface, now we need to tell the orientation, negative. Output type, element. And this is end plate to washer. Press OK. Now, between the end plate and the column of flange, we already have the contact. Now we need to create between the washer and the column flange. Right click, new, select these shell elements here. Maybe it's selecting too much. So let me use the right mouse button to deselect most of it. And then I'm going to select up until there. Maybe a little less, like maybe until here. Okay. What matters is that we select an area that is larger than the area that we know that we have contact. And then this is the positive side, middle mouse button, surface, positive side, element. This is a column, flange to nut. Press enter, right click, new, select solid facet. Now select this, middle mouse button, surface, element, and this is nut to column flange. Now we have all the surfaces created for the contact that we are going to define. I'm going to click on show all, draw mode property ID so that it looks more beautiful. There's not going to be any contact between net and washer because we are going to use here a bolt pretension strategy using the translator connector and couplings. You're going to see later. I don't know if it's going to be in this video, but you're going to see it later, and I'm going to explain why we don't need contact, and also I'm going to explain why we don't need to represent the bolt thread and the net thread. Okay. I'm going to explain this later. Now let's create the contact. Let's use this contact here that we have already, this one. And then I'm going to use the same setup. So right click and copy. Let's start by creating the contact between bolt and washer, bolt washer. This slave here doesn't really matter. Guys, you know that I have suggested you to read a blog post from my blog Learn FEA that is about contact, right? And then in this blog post, there is a part that I talk about suggestions on how to define the slave and master surfaces, right? So there are some rules. In this specific situation, since this is a surface-to-surface contact, and also since the element size is approximately equal for both surfaces, and also since the stiffness is approximately, it's not so different because we have a steel-to-steel contact. Because of all that, and also because of the size of the surfaces are not so different, then it doesn't really matter who is the slave and who is the master. Okay, so I'm going to use the question mark here to open a list to select the slave, question mark. Here we have the list, and I'm going to get here the set named bolt to washer. So I'm going to define the bolt as slave, and then in here question mark, and then washer to bolt. Double click. Now this is a surface-to-surface contact. I'm going to use a small sliding because I guess we're going to have we're not going to have so much sliding here, so we can use this formulation, which is the computational cost is lesser or smaller. In interaction F2, we have a friction F2 equals 0.44. Press ask. Now we are here again. And that's it. We can just click on OK. And in the contact pair list, we have this new contact. You see, pretty easy, right? In ANSA, we have a tool that helps in the creation of contact. I don't really like to use it. I prefer to do this in this more manual manner. Well, I'm teaching you to do this, but if I'm not teaching and I'm just doing this fast, I can do this pretty fast. And so it's not something that is not practical. It is practical. And by the way, guys, let me visualize the thickness of the shell elements just to see if I have if I don't have any penetration occurring here. So let's go to quality criteria, presentation parameters, activate draw shell as solid, apply, okay. And that looks like everything is well positioned. Let's look around. You see, it doesn't look like, it's like touching, and but there is no penetration. There must be some penetration because of numerical errors, you know, but very small. And so we are not going to face any issues. Uh, uh, Let me deactivate visualization of thickness. Guys, you see that even though we are not going to have a coupling defined here using these layers of elements in the end plate and also here, it's a good idea to have this more organized mesh around the holes, because this is a region that we are going to have contact, and it's a good idea to have a good quality mesh in a contact region. Okay, so we should always create washers. So washer is just this, we name it as washer. It's always a good idea to create washers, which are these layers of more organized elements around holes. Okay. All right, let's go to the next contact. Let's get this one, right click, copy. This one is with ID 3. I'm going to name it as washer and plate. Now, for this one, guys, if you go to this blog post, there's about contact. Let me get here. I always need to check this. So we have the fourth item of this post. There's about best practice to define master and slave. This is just something that I got from Abaqus manual or user's guide. But in the user's guide, we have this information in different places. So in here, I put it in only one place. So there is one thing here that is about stiffness of these structures. In this case, we have a plate, and it's not a thin plate. And we have the contact between the washer and plate. In this case, the thickness, the stiffness is not going to be so much different, actually. But if we had a thin plate in contact with a solid entity, probably the thin plate has a smaller stiffness if compared with the solid entity. And in this case, we would have to use, let me see here. Master surface should be chosen as the structure of the stiffer body. So we would have to choose the solid element as the master and the shell as slave. Well, even though we don't have the situation here, let's do this in this manner anyway. So as the slave question mark, I'm going to select, well, instead of trying to find the set in this list, we can simply rotate and left click here, and then it's going to select the set that has this element that we have selected, which is this one, washer to end plate. Double click and then question mark here. And then in this case, if we try to click here, we have two sets defined here. So left click, and then it's selected end plate surface. It's not this set, because this set was the one used for the contact between any plate and column. So left click again, and it's going to select another set, end plate to washer. It is this one. Double click. Now click on OK. Okay, now we have this new contact created. And now we can create the last contact, copy. This is going to be nut to column flange. Let's select slave as this one, column flange to nut, double click. And then the master to be the solid. Select here, and it's going to select in this list. Click on OK. Oh, and by the way, I guess in this one I have selected in the inverted way, right? Double click on contact, this contact here. I wanted the solid to be master, but in this case we have it as slave. So one thing that we can do is double click and select this one, right click, and then we have this flip option, flip. Okay, now we have this one as master and this one as slave. Okay, now if we check this box to see all contacts, you see that we have all these contacts defined. Looks like everything is defined as it should be. Uncheck this box. I don't like to see contact. Let me see, 40 minutes. Okay, I'm not going to start creating the connection between a nut and bolt yet, because it's going to take some time. I'm going to do something different here instead, and it's something that is very important, guys. It's going to help you a lot. First of all, let me deactivate visualization of measure by unchecking this box. And the thing here is that imagine that in the beginning of this analysis, this body here, this domain, is going to be floating in space, right? Because in the beginning of the analysis, we are going to have the contact initializing. So at first, this body is floating before the contact initializes. And Abaqus, well, this is a static analysis. And when we have a body floating, this is going to, well, this is not going to be good. We are going to have singularity of the matrix, and this is going to bring instabilities in the analysis. It's possible to have this model converged in this manner, but it's simply harder. In this case, since we have a very well modeled bolted connections with all the surfaces parallel to each other and already touching each other, there's like no initial gap here. And this is good because when we have a small initial gap, then this also brings instability in the model. Since we have a very well-defined bolted connection here, maybe this is going to converge in this manner. But I'm going to teach you a technique in case you have a more complex situation. And this technique is going to also help us in this situation because then we are not going to have unconnected bodies. If you try to run it like this, you're going to see that in the MSG file, there is going to be a message like there are 8 unconnected bodies in your model. And this means that we have 8 bodies floating in your model. Okay, and this is not good, because we have gravity in the first step, and then gravity is going to start moving this body before the contact initializes. So how do we solve this? We are going to create some springs with small stiffness connecting these bodies. And we are going to remove these springs later. So this is an advanced technique. Let's go to the Abaqus deck module. And inside elements group, we have a spring. And then left click here and then select 2 nodes because I want to create a spring connecting one node with another node. And then first of all, I want to connect, let me think here. I want to connect the washer to the end plate. I should try to avoid selecting nodes that are part of contact definition. In the case of the washer, I can't do this because both sides are related to a contact definition. So in this case, I'm going to select this node, for example, and then for the end plate, I'm going to select this node here, for example, that is not near to where we are going to have contact occurring. This part of the end plate surface is related. Well, we do have contact here actually. So maybe we can actually instead connecting this washer to this stiffener. Maybe it's a better idea. So I'm going to right click here to deselect this node and then also this one. And I'm going to select one node here to connect here. Okay, middle mouse button. And then, by the way, I guess that in this part of the screen I had in part ask always, we can just put it in auxiliary entities. And then here we have the degree of freedom. I'm going to select 1 because I want to add stiffness in the x1 direction. x1 direction is going to be defined as the direction connecting, actually as the axis passing through these two selected points. Click on OK. And then now we need to create a spring property here. So right click, new. And then this is going to be, I usually name it as stab springs. It's just to stabilize the model, but we are going to remove it later because we shouldn't have this additional element here because it doesn't exist in reality. And then degree of freedom 1, this is the property ID. And then here we have the stiffness. We can try a stiffness equals 5, which is a small stiffness, 5 Newton per millimeter. Click on OK. Double click to select this property, and here we have the spring card, node 1, node 2 ID, property, and ID of the spring. Click on OK. And there we have the spring created. Okay. Now the washer is not anymore floating because we have this node connected to this node, and this part, the beam, is fixed in the first step. Because remember, let's go back to the step manager, open step manager. You see that in the 0th step, we have this boundary condition. Actually, in the first step, I thought I had, oh, right. In the previous model, we had a connection through coupling, beam, and coupling. So because of that, we had the beam connected to the column. And then I had the column fixed here. So I had nothing floating. In this case, we need to remember to create a boundary condition to fix the beam in the first step so that the beam is not going to float. We can even do this now because it's fast. So you see, we have this boundary condition here, right? And this boundary condition fixes all degrees of freedom of this node and this node, right? I'm going to create something similar in the 0th step. So select this one, right click and copy in the 0th step, but instead of, well, we can select by set, use question mark to see a list. And there is a set that has only this node that I have used before, this one, disp node. You see? We have used it to create the history output request. Double click, and there we have it. Now we are fixing all degrees of freedom of this node in the first step while we have bolt pretension being applied. We need to remove this boundary condition in the second step. Let me click on OK. To remove this in the second step, let me see one thing here. Yeah, to remove this boundary condition from the second step, we're going to need to reset the boundary conditions and redefine only the ones that we are interested in. But let's do this later. Let me close the step manager. Okay, so you see, we have the beam fixed in the first step, and we have the washer connected to the beam. Now, because of that, the washer is not floating anymore. It's somehow connected to a part that is fixed. So we don't have singularity occurring in the stiffness matrix of the washer. Now, if I connect the bolt to the washer, I'm going to have the same thing, or actually I can connect the bolt to this part. And then I would have to create a spring like this, 2 nodes, here to here, mesomorph button, auxiliary entities, okay. And then I would have something like this. But guys, this is one technique, it works, but I don't really like it. There is one even better. You see that inside the element group, double click on spring, and then select the 2 created springs and delete. Click on OK. Instead of creating a 2-node spring, In spring group, left click in spring, in elements group, left click in spring, hold and select one node. One node means that we're going to select one node here, and then one spring is going to be created using this node, and the other node is not, it's going to be fixed automatically to the ground, let's say. It's the same thing as creating a spring with two nodes, but the other node I put in a floating position and fix all degrees of freedom of this floating node. So for example, I'm going to select this node here, this one, mesomos button, and then I'm going to select here a degree of freedom 1. Click on OK, and then right click, new, let's create a new property with stiffness equals 5, and this is going to be spring underline x, because the stiffness that we have defined here is in the x1 direction, and now this x1 direction is the global x1 direction. Click on OK, double click on this property, and then click on OK. And now you see that we have this small spring here created, oriented in the x1 direction of the global coordinate system. x1 is just x. Okay, I'm just using index notation. So x1 is x, x2 is y, x3 is z. Now, this body is not floating anymore, at least in the x1 direction. Now I need to create on this same node, left click here, I have the spring 1 node tool activated. And by the way, in here you have in part use existing, and in property use current. Instead of use current in property, let's ask always. And in part, later I need to assign these springs in a proper part. For now, let's just select use existing. Now I have this selected, middle mouse button. Now the degree of freedom is going to be 2, y direction. Click on OK, 5, and then this is going to be spring y. Click on OK, and click on OK. Now you see that we have this small spring. If I double click here in spring, I can see it better. And this one is oriented in the x2 direction, that is a global y direction. Now this bolt is not floating anymore in the y direction. Lastly, we need to create a one node spring on this node, middle mouse button, degree of freedom 3, click on OK, 5, spring z, click on OK, and OK. Double click on spring, and now you see that we have 3 springs at the same node. And remember that the other node is just have all degrees of freedom fixed. So what we are doing here is like we are fixing this node, but we are not like saying the displacement is equal to 0. We are assigning a stiffness. It's not a rigid constraint. It's like a flexible constraint with some stiffness in the x, y, and z directions. And this is going to, well, and then this body is not going to be floating anymore. What I usually do is for bodies like these, circular bodies like these, I create at least in 3 locations. So for example, I'm going to create the same thing here, spring 1 node, here, middle mouse button, and then degree of freedom 1, spring x. Okay, again, so I'm going to be faster. 2. Oh, it shouldn't have selected the property, so question mark, spring y. Okay, in here, let's just in property ask always, and again here, middle mouse button, 3. Okay, oh, it has selected the property automatically, question mark, spring z. Okay, now do the same thing here. I don't know why it's not, so ask always. So for example, this node, the mouse button, click on OK, spring x. Okay, this node, middle mouse button, 2. Okay, question mark here, spring y. Okay, this 1, 3. Let's see if it's spring is E. Okay. All right. Now the bolt is not floating. In the case of the washer, we can do the same thing. In the case of the washer, we can even do the other technique. So let's mix up the techniques. Let's see, spring to nodes. Let's connect the washer to the net. Yeah, let's do this. Let's connect the washer to the net, like this. Visa mouse button, auxiliary entities, degree of freedom 1, spring X, click on OK. Now the washer is not floating anymore, because it's connected to a body that is not floating as well. Now, it's not necessary to do this with the nut, because we're going to connect the nut to the bolt. Okay. Now, let me see. 56 minutes. To finish this video, I'm going to show you how you can deactivate this spring element in the second step, because these are just used to help in the beginning of the analysis when we have bolt pretension. And then I want to eliminate this, because this is going to add stiffness to the model that is not realistic, and we need to remove it. So first of all, go to set list, right click, new. Let's create a new set. I'm going to select springs. So in the element group, select spring, and then I'm going to create a box selection to select all springs that we have created. 10. Middle mouse button. This is an element set, and I'm going to name this as step springs. I'm going to copy, well, let's click on OK. Now, step manager, open it. And then in the second step, double click to open the second step card. And then in here we have this model change function. So left click, let's say yes to define, and I want to remove element. And then I need to put the ID of the element set here. So use the question mark and select step springs. Click on OK. And that's it. Now these springs are going to be removed from this model in the second step of this analysis. We're going to see this disappearing in meta post later. Click on OK. And now we have some time. We are almost finished, because in the next video, I'm just going to create the connection between net and bolt. And I'm going to simply copy this bolt to these other holes. And we will need to just rework on the contact definitions. So it's not going to be so much work. So in this video, let's finish with the explanation about the boundary condition reset in the second step. So let's go to step manager. You see, let's just review of what we have here. In the 0th step, we have some contact definitions. So you see that the contact definitions are in the 0th step. We have two boundary conditions here in the 0th step. This one that fixes all degrees of freedom of these two nodes, and this one that we have just created that fixes all degrees of freedom of this node. These boundary conditions propagate to step 1 and step 2. Well, it's okay to propagate to step 1 because we want this. We want to have the beam and column fixed while we have bolt pretension. Because you can imagine in a real situation that obviously that when someone wants to pass these bolts here and the washer and nut and anyways, when the person is fixing this end plate to the column, he's going to hold this beam, he's going to hold the column somehow and then create this connection. But the thing is, I don't want to propagate this specific boundary condition to the second step. Because in the second step, I am applying a displacement in the negative z direction at this node. And if I have this boundary condition propagated that fixes all degrees of freedom, then we are going to get an error. So what I'm going to do is, in the second step, double click. You see that we have resetted connector load already. Now I'm going to reset boundary as well. So select boundary. So we have boundary and connector load resetted. Click on OK. Now let's simplify here these options, and notice that in this boundary condition that we have here, if we double click on it, you see that in OP we have this option new that was selected automatically when we selected to reset boundary. Okay, so when we have OP new, this means that there is a reset in the boundary conditions. Okay, and there is also this OP mod that we can use to modify a specific boundary condition. In this exercise, we are not going to see an example of mod, but maybe in future exercises, we are going to end up seeing an example. Understanding OP new and OP mod is very, very important, guys. Okay, now, in this second step, since I have resetted the boundary condition, I need to get this boundary condition that was defined in the 0th step that fixes these two nodes, and I need to recreate this boundary condition on the second step. So I'm going to right click here, and then I'm going to copy to the second step, so define second, but it's very important to select OP new here. You're going to see that if you don't do that, you're going to get an error. You're going to commit this error probably sometimes because I have, at least I have committed this error many times, and then now I obviously memorized this. So the thing is, whenever you have a reset in a boundary condition, for example, any boundary condition that you create in this step that you have the reset should have here OP equals new. All right, so click on OK. And now you see that in the second step, we have this boundary condition here. And this one for the displacement. Yeah. Let me see if there is anything else. Oh, we don't have the connector load here yet, so we're going to create it later. Yeah, looks like everything is all right. Let's click on OK. All right. Let's save this module. This video is already pretty long, so I'm going to end this video now. You see that this module is more advanced. We are learning new techniques that are pretty cool and very useful. And well, I hope you're liking it, and see you in the next video.